So let us now look at the calculation of empirical and molecular formula. Calculation of empirical, or what we call simplest formula, and molecular formulae of compounds. So we are going to look at this, and we should know that these are two different things, the empirical formula and then the molecular formula. Can we look at some simple example? Let's look at this example here. A hydrocarbon T consists of 85.71% carbon. Full stop. A. Calculate the empirical formula of the hydrocarbon T. B. If the molecular mass of the hydrocarbon is 28, determine its molecular formula. Given generally that carbon has got a relative atomic mass of 12, hydrogen with a relative atomic mass of 1. So let us try to see how we can go about with the calculation of the empirical formula of this hydrocarbon and then the molecular formula, given the relative atomic masses. And we can see from here that the percentage purity, the percentage composition of carbon has been given is 85.71% in this hydrocarbon T. Now, a hydrocarbon, we must know what it is. It is a compound that consists of carbon and hydrogen atoms only. That's a hydrocarbon. Meaning that if 85.71% is the percentage composition by mass of carbon in this compound, that means the rest is the percentage composition by mass of hydrogen. So in our solution that we are going to have right now, the first thing we need to do is to get the percentage composition, that is the percentage of hydrogen in this compound. If this one here, 85.71% is for carbon, it means that the rest that makes up to 100% is for hydrogen. So we shall have to subtract the 85.71 from 100. So 100 minus 85.71, and this one gives us so 100 minus 85.71% gives us 14.29%. Please, you need to start by working out this because you cannot go ahead and calculate anything when you don't have the percentage composition by mass of the second element or of the other element in that compound. So we have the percentage of hydrogen. Now let us go to the calculation of the empirical formula. When we are calculating the empirical formula of a compound, there are some steps that we are supposed to follow, and we are not supposed to skip any step. The first step is to write down the chemical symbols of the elements side by side in one row. So we start with the elements. These elements are carbon and hydrogen. Make sure that the chemical symbols are a bit far from each other because you may have a long decimal number, so it should not contradict with what is under the next element. So in this case, carbon is here, hydrogen is here in one row. Then next is we need to put down the percentage composition by mass of each element. So for carbon it is 85.71 and that of hydrogen is 14.29. That's the percentage composition. There is no need for me to put percent here because I've already talked about it here. Next is we need to know the values of the relative atomic mass of each element, which have already been given here. So for carbon it is 12 and that of oxygen is, that of hydrogen is 1. Next is we are going to calculate the number of moles of each element in the compound using the percentage composition and the value of the relative atomic mass. So we now go to the step of getting the number of moles. So if we want to get the number of moles of carbon, we are going to divide the percentage composition, which is 85.71, by the relative atomic mass, which is 12. Likewise here for hydrogen, it will be 14.29. We divide it by 1. And then we put an equal sign to show that we are getting some values from this expression here. So 85.71, we have to divide by 12. And this one gives us 7.1425, and this one gives us 14.29. Now mark you this. Never try to round off. Let me put it here for you so that we don't forget. Do not round off. Reason being, if you round off in this case, then you'll be moving away from the correct answer. You'll be going to an approximate answer in this case. Make sure that you do not round off at this stage. Even if it is a very long decimal number, you leave it the way it is. Then we are going now to what we call the mole ratio. Remember that we are moving towards what we call the empirical formula, which is a formula which expresses the ratio of the number of moles. That's what we call the mole ratio. So in getting the mole ratio, we shall be dividing the number of moles that we have got from here by the smaller number of moles. So this one, the mole ratio will be 7.1425. We are going to divide it by itself because it is smaller, 7.1425. Even this one here, 14.29, we divide by 7.1425. What we get from here is the correct answer, which will be our mole ratio. Please still do not round off anyhow. So this one gives us a ratio of 1 to, let's get this, 14.29. We divide by 7.1425. This one gives us 2.000700035. Now at this point, when you have got the mole ratio, you need a whole number, or you need whole numbers here, but this one is a decimal number. When you reach this point, you are free to round off 1 decimal place. Try to round off to 1 decimal place and see what you get. You are supposed to get either a whole number or a number which is simple to deal with, even if it is a decimal number. So this one gives us a ratio of 1 to 2.0, and 2.0 is just 2. Now, let me use this part here. When you have got this, please show that the number of moles of carbon atoms here is 1 in this ratio. So it will be C1H2. This one tells me that the ratio is 1 to 2. If you leave it, or suppose it was say 2 to 2, if it was 2 to 2, then in this case it means that the ratio is even 1 to 1. So we first give this one to show us the actual ratio, then we can conclude that therefore the empirical formula of T is CH2. Even if we don't put this one here, it's already here. But we have put this one here for the purpose of showing that the mole ratio is 1 to 2. So this is the account of how to get what we call the empirical formula. Follow these steps here. So that is that. We are remaining with getting the molecular mass. So let us wind up very fast in getting the molecular formula, in this case very fast. The molecular formula of this compound here, as we have already seen, we are supposed to multiply the empirical formula by the simplest factor n, which we don't know. So our molecular formula is CH2. If we multiply it by some value n which we don't know, it must give us the molecular formula whose molecular mass has already been given to be 28. So this one must give us 28. Now what we are going to do is, in order for us to get the value of n, we are going to get the empirical mass here in this case and then make n the subject. So our empirical mass will be n times 12 plus 1 times 2. It should give us a total of 28. So 12 plus 1 times 2 is 12 plus 2, which is 14. So this one times n gives us 14n, giving us a total of 28. Now this is a very important step that will give us the value of n. N is got by dividing 28 by 14. Don't forget this step here. It's a very important step. Because if you get this, if you divide this one here by this, you are going to get the value of n, and n in this case becomes 2. Then finally we substitute for the value of n. We just substitute directly and say the molecular formula of T is, then let's substitute for the value of n. In this formula here, we shall multiply the number of carbon atoms by 2, which becomes C2H, and then this is 2 times 2, which gives us a total of 4. And that is the formula of the compound. That's the molecular formula. So what we have seen is how to get the empirical formula of the compound and then the molecular formula of the compound, given the molecular mass of the hydrocarbon or of that compound. Remember, if it was the vapor density, then we would multiply the vapor density. If this one was the vapor density, we would multiply it by 2 to get the value of the molecular mass of the compound. So, thank you for watching in this case.